Welcome to my next video, Similarity, Practice Set 1.2. Practice Set 1.2. First problem. Given below are some triangles and lengths of line segments. Identify in which figures ray PM is bisector of angle PQPR. Now first problem. Observe the figure. Now here we have to identify whether PM is angle bisector of angle QPR. For this we know that a theorem, that is converse of angle bisector theorem. What is that? If in triangle QPR point M on side QR such that QP upon PR is equal to QM upon MR, then ray PM is angle bisector of angle QPR. Okay. Therefore, we have to solve this problem like this. Here QP is equal to 7, PR is equal to 3, QM is equal to 3.5 and MR is equal to 1.5. Therefore, we have to find out the ratios. QP upon PR is equal to 7 upon 3, that is equation 1. QM upon MR is equal to 3.5 upon 1.5 is equal to, now multiplying numerator and denominator by 2, we get QM upon MR is equal to 7 upon 3. From 1 and 2, QP upon PR is equal to QM upon MR. Therefore, by converse of angle bisector theorem, ray QP is angle bisector of angle QPR. Now second problem. Observe the figure. Here RP is equal to 7, PQ is equal to 10, RM equal to 6, MQ equal to 8. As we have seen earlier, we have to make two ratios. These are RP upon PQ, ratio of sides of angle. RP upon PQ is equal to 7 upon 10, that is equation 1. And second ratio RM upon MQ is equal to 6 upon 8. From 1 and 2, RP upon PQ is not equal to RM upon MQ. Therefore, by converse of angle bisector theorem, ray PM is not angle bisector of angle QPR. And next problem is homework for you. Okay. Now the second problem. In triangle PQR, PM is equal to 15, PQ equal to 25, PR is equal to 20, NR equal to 8. State whether line NM is parallel to side RQ. Give reason. Here PM is equal to 15, PQ is equal to 25, PR equal to 20 and NR is equal to 8. Now we know that the converse of basic proportionality theorem, that is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. To check the equality of the ratios, we require the distance PN and MQ. Now PN is equal to PR minus NR is equal to 20 minus 8 is equal to 12. Also MQ is equal to PQ minus PM is equal to 25 minus 15 is equal to 10. Now in triangle PRQ, PR upon NR equal to 12 upon 8. On simplification we get 3 upon 2. Also PM upon MQ is equal to 15 upon 10. On simplification we get is equal to 3 upon 2. Here PR upon NR is equal to PM upon MQ. Therefore, by converse of basic proportionality theorem, NM is parallel to RQ. Okay. Now third problem. In triangle MNP, NQ is a bisector of angle N. If MN is equal to 5, PN equal to 7, MQ is equal to 2.5, then find QP. Solution. In triangle PNM, ray NQ is a bisector of angle N. Therefore, Mn upon Np is equal to MQ upon QP because of angle bisector theorem. After putting the values, we get 5 upon 7 is equal to 2.5 upon QP. After cross multiplication, we get QP is equal to 2.5 into 7 divided by 5. On simplification, we get 3.5. Hence, the measure of QP is 3.5 units. Now, fourth problem. Measure of some angles in the figure are given. Prove that AP upon PB is equal to AQ upon QC. Solution. In figure, angle APQ is equal to 60 degree and angle ABC equal to 60 degree. Since the corresponding angles, angle APQ and angle ABC are equal, therefore line PQ parallel line BC. In triangle ABC, PQ parallel BC. Therefore, AP upon PB is equal to AQ upon QC because of basic proportionality theorem. Next problem. In trapezium ABCD, side AB parallel side PQ parallel side DC. AP is equal to 15, PD is equal to 12, QC equal to 14. Find BQ. Solution. In trapezium ABCD, side AB parallel side PQ parallel side DC. AD and BC are transversals. Then, by property of three parallel lines and their transversals, AP upon PD is equal to PQ upon QC. Putting the values, we get 15 upon 12 is equal to BQ upon 14. After cross multiplication, BQ is equal to 15 into 14 upon 12. On simplification, we get BQ equal to 17.5 units. Okay. Now next problem. Find QP using given information in the figure. Solution. In triangle MNP, NQ is angle bisector of angle MNP. Therefore, MN upon NP is equal to MQ upon QP. Angle bisector theorem. Putting the values, 25 upon 40 is equal to 14 upon QP. After cross multiplication, we get QP is equal to 14 into 40 upon 25. Therefore, QP is equal to, on simplification, we get 14 into 8 upon 5. On simplification, we get QP is equal to 22.4 units. Next problem. In the given figure, if AB parallel CD parallel EF, then find X and AE. Solution. In figure, AB parallel CD parallel EF. Line BF and line AE are their transversals. Then, by the property of three parallel lines and their transversals, BD upon DF is equal to AC upon C. Putting the values, we get 8 upon 4 is equal to 12 upon X. On cross multiplication, we get X equal to 12 into 4 upon 8. On simplification, X equal to 6 units. Here, AE is equal to AC plus C. Putting the values, A equal to 12 plus 6. C means X and X equal to 6. Therefore, A is equal to 18 units. Eighth problem is homework for you. Now next problem. In triangle ABC, segment BD bisect angle ABC. If AB is equal to X, BC is equal to X plus 5, AD is equal to X minus 2, DC equal to X plus 2, then find the value of X. Solution. In triangle ABC, ray BD is angle bisector of angle ABC. Therefore, AB upon BC equal to AD upon DC. Angle bisector theorem. Putting the values, X upon X plus 5 is equal to X minus 2 upon X plus 2. After cross multiplication, we get X into X plus 2 is equal to X minus 2 into X plus 5. Now multiplication, X into X, X square plus X into 2, 2X. is equal to x into x plus 5 minus 2 into x plus 5. Therefore, x square plus 2x is equal to x square plus 5x minus 2x minus 10. X square get cancelled. 2x minus 5x plus 2x equal to minus 10. Therefore, minus x is equal to minus 10. Therefore, x equal to 10. Okay. Next question. In the figure, x is any point in the interior of triangle. Point x is joined to vertices of triangles. Segment PQ parallels segment T. Segment QR parallels segment EF. Fill in the blanks to prove that segment PR parallels segment DF. Proof. In triangle XDE, PQ is parallel to D. Now here we have to fill the blank space. This statement is given. Therefore, we have to write here given. From this statement, we can write according to basic proportionality theorem next equation. Therefore, XP upon PD is equal to XQ upon QE. That is basic proportionality theorem. Next, in triangle XEF, QR parallel EF. That is also given. From this, we can write XR upon RF is equal to XQ upon QE. That is also basic proportionality theorem. Now from equation 1 and 2, we can write next statement XP upon PD is equal to XR upon RF from 1 and 2. Therefore, segment PR is parallel to segment DF, converse of basic proportionality theorem. Okay.